All right, make me feel it. Class?
Yes.
I didn't hear everyone. Where were you there? Where are you there? Come on. Come on. Let me. One more time. Make me feel it. Class?
Yes.
All right, so I want you guys to at least pretend like you want to be here, because that makes me excited to be here, to come up in front of all these students and try to preach to people that don't want to listen to me, that can't wait to just walk out of this classroom. I am trying to make you pass. I'm trying to make you graduate. Y'all bunch of seniors, I would like to see you all graduate, because I don't want to see y'all ever again. Once this year's over, go on, live your life. Go do great things, okay? Okay, the only thing that you're going to have good, about this class is just good memories of how great I was. Yeah, see? At least I could actually make you laugh. Now, let's take a look at this. Normal z-scores. What? You do? Using my corgis. Yeah, I know, right? Today would be a non-shoe day, but it was kind of chilly this morning. But I would wear my mandals. But there is someone in my 7th hour that always eyeballs my toes, and yeah, huh?
Me too.
Wow, that's weird.
You don't have shoes?
That's a weird fetish. That's weird. Stop staring at people's toes. Why do you gotta take pictures of people's feet?
I don't take pictures.
Oh man, then don't stare. It's kind of weird. Anyway, normal z-scores. So from Tuesday's notes, on the notes from Tuesday, what do we know about a normal curve? It's a bell shape, right? So the normal curve is going to be bell shaped, and we're also going to add those other things that we had, which is the 68%, the 95%, the 99.7%. We're going to have all of those also in there. So as part of this, those are my normals. And we're going to talk about z-scores, which are referring to a point either going to be less than, greater than, or an area under that. We're looking for the percentage of that. So now, what I'm going to do is, I have a couple things. So z-scores tell us how far in terms of standard deviation a given element is from the mean when. Now, the symbol, the Greek symbol mu, is the same as my mean or my average. That's the Greek mu. And then we have sigma, which is right here. That's going to be the same on my calculator as my SX. My standard deviation is SX on the calculator. It says to find the area or percent of data under the curve with z-score is given. We have it here. This is everything you need. This is everything, all steps. So if you're one of those people like underlining, highlighting, all that good stuff, there's highlighters in the back because this is step by step, super important. Step by step. So you could go through and do everything just by reading this. Just by reading this. You can get an A on all this right here. So we're going to do example 1 given these instructions. So first thing, it says draw a diagram of the normal curve. Here it is. Here's your diagram that you're going to use. This is example 1. Normal curve and shade the area you're looking for. Okay, let's take a look. It says what percent of standard normal model is found in the region where z less than, remember alligator eats less than, alligator eats the bigger number here, right? Come on. There you go. If you can't see that, z is going to be less than 1.67. Now, I need to put in, where is 1.67? It's going to be right here in between 1 and 2, right? And I'm going to call that 1.67. Where z is going to be less than, what numbers are less than 1.67? What side of my line is less than 1.67? To the left. Very good. That's what I'm looking for there. I want everything to the left. So that's what it means by drawing it. Okay, draw your normal curve and the area you're looking for. So that means that all this here is what I'm looking for. Everything over there. Make sense? We drew it. Now we're going to look it up using our calculator. Go to the calculator, documents, and it says add calculator, right? Yes? Add calculator. So we could do it here. So I did new document, home, new document, add calculator. So instead of doing list and spreadsheet, which we've been doing every single time, we're now just using calculator. So right here, the next step would be menu. Right? You guys following through? Menu, statistics, distribution, normal CDF. All right? That's where you go. So everyone get to that point. Write me out, please, on your calculator. Write me out on your calculator. You're getting that far. That far on your calculator. Does anyone need help getting there? Deja, you good? Okay. Anyone else need help? Yes. Okay, so we are at right here. So calculator, menu, statistics, right? So statistics. There we go. All right, so stay right there. I'm going to help you guys enter all this in. Anyone else? So, right here. So, we're right here on this. So, calculator, menu. Now we're at statistics. Next one is distribution. After that is, there we go. Click on that. All right, so now, wait right there. So now, at that point, we're going to use our information. We're going to use the information there. Lower bound. On my graph that I have, which is right here, how far to the left is it going to go? Okay, it's past that though, right? But since it's all the way to the left, I want everything all the way to the left. What's the note say if I'm going for the lower bound? What's it say in the notes? Very good. Yeah, so it says use negative 9.99. So it says that right there in the notes, you're going to use a lower bound from negative 9.99. All right. Now, how far to the right did my go? No. On my graph. I just want to look at my graph. What was shaded on my graph? Where did I stop at? There we go. So that's what I'm looking at. So since I was going all the way to the left, just up to 1.67, that's where I'm stopping at. So my upper bound here is 1.67. Now, for this one here, does it say anything different about my mean? Does it say anything different? Does it give me a different mean? Does it give me a different standard deviation? It doesn't give me different on either of those, so I keep that and I hit OK. So the percent that is shaded, that would be from 1.67 all the way to the left is going to be, as a decimal, 0.9525. That's a decimal. But I need to rewrite that as a percent. All right. So it's going to be 0.9525. Now, to turn a decimal into a percent, you just go like this. Take this decimal point and move it to the right. Move it to the right, so my percentage now is going to be 95.25%. The answer will be in decimal, considering total area is 1 instead of 100%. but you may change the answer percent by multiplying by 100, and that's what we do by moving this over too. So 95.25%, and you always want to have at least 2 decimal points right here. Questions? Is that pretty easy there? Kinda? Hopefully? Yes? All right. Now we're going to do example 2. Same steps. I want you people right now to do step 1. Step 1. So what was the first thing? Since the curve is here, and fill in what we have. All right, let's see what information we have. We have my curve. We have the standard deviations already set. And it says a region found where z is going to be greater than, negative 2.04. So negative 2.04 should be slightly to the left of the negative 2. There you go, that's a 2. And alligator eats bigger. So it's going to be to the which side?
Right.
Yeah, it's to the right. Is everyone following on that one? This is to the right. So I'm going to go through and shade all this. All right, so now let's take a look. According to my graph, according to what I actually colored in here, what's the lower bound? Negative 2.04. And the upper bound, how far to the right is this going to go?
9.99.
9.99, because we go all the way out, right? All the way out. So let's go ahead and do that, please. Same steps, but I don't have to make my calculator. I don't have to do a new one. I don't have to do a new one. I just need to get to this place right here, and now I can just put them all here. So same steps: menu, statistics, distribution, normal CDF. You entered it already? Okay, good. All right, does anyone need help entering it? All right, let's see what we got. So my lower bound was negative 2.04. My upper bound was 9.99. Did we change the mean? No. Did we change the standard deviation? Nope, so I hit OK. So the percent that is greater than, my negative 2.04 is going to be 9793. So as a decimal, I get 0.9793. And then it turns into 97.93%. All right. Anyone questions here? Are we good? Did y'all hear? You feeling good? Good. All right. Anyone else questions? This should be pretty straightforward here. And next one, example 3. Now, example 3 is slightly different because the notation. Ooh, no. That's my last word. The notation is slightly different. So as this is referring to an interval. So in my bound, so z is between these two numbers. So the lower here is negative 0, 0.51, and that's less than Z, which is less than 1.26. So what that means is the lower bound's here, the upper bound is here, and I have to find the value in between. So negative 0.51, right about here, and 1.26. And I'm trying to find everything in between here. So, go ahead, set it up on your calculator, please. Set it up. You're going to do the same thing over and over and over again. We're just changing the numbers that we're plugging in for our CDF. All right. Yeah, go ahead. Menu, statistics, distributions, normal CDF. My lower bound we said was negative point, was it 51?
Yeah.
Very good. Upper bound?
1.2.
Very good. Mean stays, standard deviation stays. Hit okay. So my percentage is going to be, yes, 5911. Now, as I'm doing this, I don't know if you guys noticed it yet, I'm always looking at 4 here. But I also am looking at the next number. Is 3 going to round up or drop off? Drop off. Because you would round up if it's 5 or above. But on all these other ones here, it was always 4 or below. But this one right here, same thing. This one's a 3, so that's going to drop off. So I do get 0.5911. Which as a percent is 59.11%. You guys feel pretty good about this? Hopefully. Now, here's this one right here. Then after this one, we're going to take a short break, and I'm going to give out some of these homework things that you guys are supposed to be missing. Now, what this says right here, standard model is found in the region of absolute value of Z is greater than 0.72. Now, absolute value means it's always going to be what?
Positive.
Positive. Thank you. Always positive. But let's think about it like this. Negative 0.72 and let's go this and 0.72. If I put a negative right here inside this, what's going to happen because of this absolute value? It's going to turn positive, right? So it's going to turn positive. So is that going to be true? Yes. So it is possible when I have an absolute value to have 2 different answers. I have an answer at positive 0.72, which is right here, and negative 0.72. Because the absolute value is like that, we set it up as being 2 different things. Now, this is going to be super important here. And I'm going to teach it to you like this, and it's the easiest way I have. A lot of people actually did very good like this. We're trying to figure out numbers for this. And so I'm going to test numbers, which I think is going to work. So I'm going to plug in numbers here. We have this broken up into 3 parts. We have the left part, we have the middle part, and we have the right part. So to see if it's going to shade, let's pick a number. I'm going to pick a number on the right-hand side. 2. So is absolute value of 2 greater than 0.72? Yes? Yes? You guys agree? So that means that all this is shaded. So all that's shaded. Yeah? Now let's pick a number for the middle. What number is right there in the middle? So absolute value of 0, is that greater than 0.72? No, it's not, is it? It's not. So this one doesn't work. So this piece in the middle is not shaded. Now let's pick a number on the left. Absolute value negative 2. Is that greater than 0.72? What does absolute value do? It turns it positive, right? So if it turns it positive, does that mean that's going to be greater than 0.72? Yes. By testing this out, we just proved that the right-hand side over here is going to be shaded and the left-hand side over here is going to be shaded. Does that make sense? Yeah? No? Maybe? Okay. Are you okay with the fact that I'm going to have a positive and negative 0.72 because it's absolute value? Okay, now I'm just picking numbers. So since I broke it up into different parts, let me try this one because this one worked. Right here. So this bar right here is my positive 0.72. This bar right here is negative 0.72, right? So what these are is just picking numbers in that region. So I just wanted to pick a number somewhere over here, somewhere to the right of this, because I have 3 different areas. I have all of this, I have this, and I have this, right? 3 different areas. So area 1, area 2, and area 3. So I picked a number from area 3, which is over here, and I like using whole numbers. So that's why I picked 2. I picked positive 2 because it's right there, it's part of area 3, and as I plug it in, the absolute value of 2 is greater than 0.72, therefore I shade it. We did the same thing for 0, that was in area 2, and let's see, it did not work out, so I don't shade that. And then I picked a number over here on the left hand in my first area, which was the negative 2. But then the absolute value of negative 2, absolute value means it's always going to be positive. Any number inside there is going to be positive. So from there, it makes it positive. So from this actually is going to become 2 is greater than 0.72. Because that absolute value bar does that. So that's true. So therefore, I shaded the left side. All right. So anyone else? Question there? Now, what do you think about both of these sides here? Are they the same size?
Yeah.
They are the same size. So let's go ahead and just start by finding the area of the left one. Let's find the area of the left one. So the area of the left one would be my lower bound. Jake Wellen, sit up please. You got your calculator in your hand? Yeah. So, calculate this. So, menu, statistics, distribution, normal CDF. My lower bound would be my negative 9.99. And just for the left side, what is going to be the upper bound for the left side? Negative 0.72. And do I change the mean?
No.
Do I change the standard deviation?
No.
Hit OK. So this is going to be Now, this is super important here that we were paying attention. So 0.2357. Now I look at the next number. Next number's a 6. What does 6 do? Goes up. So it means it's going to make this 7 become 8. So it's 2358. And over here. Okay. So this is going to be 0.2358. So as a percentage, that turns into 23.58%. And that's just this area 1, right? Hello. All right, that's just as area 1. We still have to do area 2, but do I have to do the whole thing over again? Say no. Oh, thank you. All right, you need keys. There you go. All right, so area 3 over here is also going to be 23.58%. So together, or you could either add them together or just have your calculator do it. So watch this, watch. Your calculator is like super smart. Watch this. Arrow up, it's highlighted, hit enter, and then times 2. So I get 0.4715. Which is going to give me 47.15%. Yes? No? Y'all falling asleep on me, seriously. Okay. It's super easy, right? I hope so, but I'm trying, and I'm gonna be like super mad. I'm gonna like and like kill myself if y'all don't get 100% on these questions. This should be easy. So I'm gonna pause the video, write meow, and this is what I would like for you people to do. If you're one of those people that are missing a bunch of assignments from Unit 3, I made extra printouts for you. You can come get the ones that you're missing. And if not, this is what you're going to do. Alrighty, now we took a little short break to try to do some of the problems. So if you could please, make sure all those headphones, phones, TikToks, all your Snapchats, your Weibo chat, your, what's that other one from no, yeah, your Tinder or, no, what's that other one that's like the Chinese one that people use for calling people internationally? Huh? WhatsApp. There we go. Put it all away. So I know you're paying attention to me. Not implying that anyone currently is playing on their phone and not paying attention to me. Alright, you got this. So, what we have here, for this one right here, when a z-score is not provided, this one's actually going to be pretty straightforward, pretty easy here. Okay, when a z-score value is not provided, we can figure out using this formula right here. Jahir, if I have to mention and come all the way back over there, I'm not going to be happy. So, data value minus mean. So, it's whatever x value they give you minus the mean, that's my mu, divided by standard deviation. Take your z-scores out, 2 decimal places. That's what we're talking about for all of our percentages that we've been doing. They've all been 2 decimal places. Now the next one, it says, normal has a mean of 50, a standard deviation of 5, and an x of 55. So we're going to find the z-score for this. So to get my z-score, so z is equal to x, which is 55, minus mu, which is 50, divided by 5. Everyone following? So 55 minus 50 gives me, which is positive 1. Now, there's a reason why I put a plus sign right there. Because all my standard deviations are either to the right, which are positive, or to the left, which are negative. So all of them, it's either plus 1 standard deviation or minus 1 standard deviation, or somewhere in between. I like putting a plus sign so I always will know that's going to be 1 standard deviation to the right.
Is that it?
Yeah, that's it. Está muy fácil. See? See? All right, let's do B then. I would like for you people, right meow, to do B. Right about meow. Look at me. This one should be a pretty cool one. Yep. Close. 43 minus 50. Are you sure? You want to bet on that? Are you willing to bet on that? It's not. You ever tried talking to it nicely?
No, you do.
No? That's what I do. What's up? Oh, control enter.
Sorry, you're good, you're good. I was like, wait a second. I think what's going on? Grab the X's.
Right then. Where are you? Here, let's do it. What's your number? Try again. Anyone else? Give me a seat. Give me the answer. Give me the answer. I don't know why. How do you get 430? 430. Oh, because you used the wrong symbol. You used the negative instead of the minus sign.
Yeah, always this way, because that's the
No, it's not.
deviation. That's what you're dividing by. It is for you.
All right, let's see what we got now. So, write it out.
No, it doesn't. Well, it just reminds me.
43 minus 50 over 5. So this is going to give me negative 7 over 5, which comes out to be negative 1.40. Did you leave it as a fraction? Yeah, 2 decimal points. Okay, even though it's exactly 1.4, I just put a there so we always have 2 decimal points. Is that easy? Okay. Anyone else? Anyone else questions here? Alrighty, let's look at the next. We have a couple more to do, and then from there, it should be pretty easy. Now this one, we're gonna do the same thing that we were doing on the first page, the first 2 examples, but now we actually have a different mean and a different standard deviation. It says right here, assume that waiting times for customers at a popular restaurant before being seated for lunch are normally distributed with a mean of 12 minutes. So right here, here's my meal, and standard deviation of 3 minutes. So the space in between here to here, so this would be my plus 1 right about here, right? This would be my plus 1, this is going to be my plus 2, and so in between these, it is going to be 3 minutes, right? That's the width of each one is 3 minutes. Find the percent of customers who wait at least 12 minutes. So let's go and find 12. Right here, right at 12. So at least 12 minutes. So think about that. Can it be more or less than? It's more than. So the word at least means the smallest amount, your least amount, is going to be 12. So what do I know from 12 all the way this way? What percent is that?
Oh, 50.
That's 50%, because that's the mean, right? And that we know that half of the data is on the left, half of the data is on the right. This is 50%. Is that pretty straightforward there? That's the answer. Yeah. Okay, what percentage waited, find the percent of customer who waited at least 12 minutes. So 12 minutes or more over here. That's 50% of the people waited 12 minutes or more. Now, let's go down to the next one. Between 9 and 18 minutes. So, I got my mean in there again. So 9, let's go ahead and look here. So between 9 and 18. Between 9 and 18. So we're going to do the math on this one on the calculator. Because the rule that we have of being the 68 and the 95 is just an approximation. It's an approximation. I want you to get the exact answer here. So we're going to take our calculator. What's my lower bound here? 9. My upper bound is?
18.
Very good. So I'm going to, before I get into all that, fill that in. There you go. So, back to the calculator. Menu, stats, distribution, normal CDF. This one, we said the lower bound was what? 9. So I'm going to enter 9. Upper bound was 18. Mu, what is my mean? 12. So I changed this here to 12. And my standard deviation here is 3. Does that make sense? Anyone questions before I hit enter here? Good. Alrighty, let's go ahead and hit enter. So the percentage I come up with is, let's see, I get 0.81,
86.
yes, 86, 0.8186. So it's going to be 81.86% in between. So in regards of my word problem, what can I say in regards to word problem? So that we have a bunch of these on the homework and on some of the problems that we're going to have. What's it mean in context of the problem?
81.86.
Say it again, loud and clear.
That about 81.86% of people waited between 9 and 18 minutes.
Very good, perfect. That's in context of the problem. So the word problem is stating that these people are waiting a certain number of minutes. So he said 81.86% of the people waited between 9 and 18 minutes there. Does that make sense? In context of the problem, I have to read and try to understand what the data is telling me. Now this next one says at least 17 minutes. So that means the least amount is going to be 17 minutes, right? I'm going to put 17 on here. So if that's the least amount, what side of this am I shading?
Right.
Very good. I'm shading the right side. I'm shading the right side. Now this is going to be another interesting one because we normally, if I go all the way out, what does it normally go to? 9.99, right? It goes out to 9.99, but isn't 9 way over here on the left?
Yeah.
So all that we did for the 9.99 is on the standard with the mean is 0. What we're doing here is just take it out far enough that I could actually include all my numbers. So what I'm going to do is just find a big number. I'm going to throw in a big number there to make this work. So here we go, menu, statistics, distribution, normal CDF, and my lower bound we said was 17. My upper bound, so now I'm going to go 99. That's a big number all the way to the right, isn't it? So I'm just picking a big number far to the right to make sure all my data is going to be included. What was the mean and standard deviation?
3.
Now, it doesn't matter about this number right here, especially if it's going all the way to the right. It just needs to be big. Just to me, needs to be a lot bigger than what I have here. So there we go. Now I get 0.0478. So we get 0.0478. So that tells me that there's 4.78% of people. So 4.78% of the people waited how long? Waited 17 minutes or more. That's what we're looking for there. Does that make sense or no?
Yeah.
Nonsense? Sense? Okay, good. Less than 8 minutes. So I'm going to put the 8 in here. So less than 8 minutes. So what am I shading on this one now?
Left side.
The left side. Very good. So it's going to be left side here. So all of that. So my lower bound for this specific problem, what can I say for lower bound? Yep, negative, I'll just say 99, because I need a big number.
Oh, that's right.
Remember, I need big numbers, so it's going to be a big negative. So that's why I said negative 99. So it's far beyond all of this. That's what I'm going for. Menu, statistics, distribution, CDF, and negative 99. Upper bound we said was 8. This is my mean, which is 12, and standard deviation is 3. Yes? All right. And so we get, for this one here, we get, oh, what happened to it? Did I delete it? Dang it, I did. 9 point what? 9.12? Okay. No, I do. I just want to, I'm recording this for, prosperity.
So they don't trust us.
Well, I know they don't trust you guys. I do. I always trust you guys. So since I am loading this to YouTube, and because I have other people from other classes that watch my stuff, I want to make sure I'm always correct and want to show them all. So we get, what do you say? 0.
9.4.
So 9.12, right? So we're going to get, so 9.12%. All right, questions, concerns, complaints, comparison theories.
Why don't we do that anymore? We did it last year.
I know, but it doesn't really fit in this 90-minute classes. The regular class time.
90 minutes to talk about conspiracy theories.
I know, but if people would talk more, then it would actually make life go a whole lot. Like the class go better.
I would always.
I know. I would have the same 3 people talking about all the time.
It was me, Adriel, and Kobe.
Yes, same 3 people talking all the time. So, but for those people that missed out, we would actually talk about conspiracy theories all the time. That, huh? I know.
He does a lot.
Yes, aliens do exist. Yeah.
Really?
Right there. There's one right there.
If you were not my teacher.
Why? Yes. Huh? What's that Facebook guy?
Mark Zuckerberg?
He is a robot.
He's a lizard.
He's a robot. A robot lizard.
Look it up. I want to see it.
All right, you guys. So this is what we're gonna do. We're gonna use the rest of this time wisely.
Wait,